All right, let's talk about moral philosophy and the problem of free will. Many philosophers argue that one can only be morally responsible for actions that are performed freely. For instance, we don't hold people morally responsible for things that they are forced to do. For example, if you're held at gunpoint or if you're blackmailed for something, you're not going to be held morally responsible. For instance, if I um, if I point a gun at you and say, "I want you to rob Professor Sherbart's car," and then you do it for fear of your life, you were in a sense forced to do it, and we would be hard pressed to hold you morally responsible for the stealing of the car. You really couldn't have avoided it. The only way you could have avoided it is if you chose death. Same thing goes for the case of blackmail. If I said either rob Professor Ryan's car or, I'm going to send these salacious photos of you all over the internet, then that seems to at least mitigate, if not completely destroy, your moral responsibility for the action. So if we don't have free will, then it seems that ethics goes out the window. And since this whole semester we've been trying to figure out what the right theory of ethics is, all of this will be for naught if we can't defend the notion that we have free will. Well, it turns out that philosophers and scientists believe that there are compelling reasons to question whether or not we have free will. And this thinking goes all the way back to the ancient Greeks. But in the 18th century, when scientists like Newton started to discover laws of nature, there began this worry of a view called determinism. So why don't you pause for a moment and watch this clip from a film called Waking Life that has a lot of rich philosophical content. But there's a philosopher talking about the basics behind determinism. Determinism, loosely, is the view that the laws of nature, like the laws of physics, chemistry, biology, in conjunction with the past or prior conditions, entail the future conditions, and entail what's happening now. So you think of the timeline, the history of the world, as like a single train track, and we like to think that the future has open possibilities. I could do this or that or some other thing, but that might be an illusion, and what is laid out in front of us might be a single track because of the past and the laws of nature. So that's the train track analogy. We skipped over the pool table metaphor. Imagine a pool table right before the break. So you've got the white ball, the cue ball, which is about to be struck toward the 15 other balls that are set up in that triangle. Let's say that you're going to break. You're going to strike the cue ball with your pool cue or your pool stick. And then right before you strike the cue ball, we freeze time. Now, if we knew enough about geometry and physics and the angles and all of the conditions of the pool table, the friction of the felt, the mass and density of all the balls, then it would be pretty easy to figure out, to perfectly predict what's going to happen after the break. We could predict that, well, the cue ball is going to accelerate toward the 15 other balls in the triangle with this velocity, and then there will be a chain reaction. The balls will disperse in this particular way. Maybe the 3 ball will bounce off the left rail and then the top rail and then end up near this corner pocket. Maybe the 8 ball will bounce off the 2 ball and get dangerously close to a side pocket. In effect, billiard balls on a pool table don't have free will. Their behavior is completely governed by the laws of physics and geometry and the prior conditions, the past, what came before it. Billiard balls are just hunks of matter. But in the Waking Life clip, the argument is that we're not that much different than pool table balls. We are also hunks of matter. I remember watching this Star Trek episode, and the Enterprise encounters these aliens that are quite different from human beings. And the way that the aliens describe human beings is in the most general terms, and they call us bags of mostly water. If you think about it, that's a crude description, but it's not particularly wrong, right? Our bodies do contain all of our internal organs and blood and bones, etc. And if you talk to scientists, we are mostly made out of water. Our bodies are 75, 80%, something like that, amount of water. So we're kind of like walking containers of water. We're made out of physical stuff. We're a big chunk of atoms. And the laws, we're physical beings, and the laws of nature are going to govern what our physical bodies do. So are we any different than pool table balls? Well, some might say, well, of course there's a relevant difference between pool table balls and human beings. We're special. We have consciousness. We have a brain. Maybe we even have a soul. So for that to be right, you've got to defend the existence of maybe some non-physical entity like a soul or maybe even consciousness or a mind. That might be a tall order. If it comes down to it, we might be different in complexity, but not different in kind. We're still a hunk of physical stuff. And as it's described in the Waking Life clip, you can see how our behavior plays out in a scientific or physical sense. That there's some electricity, some firing of neurons in my brain, and that will send an electric signal down to my, say, arm. Muscle fibers will twitch, and then you've got movement of the arm. Is that really so different than what's happening on a pool table? And we can trace the prior conditions all the way back to the beginning of the timeline. So it's not exactly clear where that goes, but from some scientific perspectives, that would be traced back to the Big Bang, 13 or 14 billion years ago. There was a massive explosion billions of years ago. A lot of energy was released, and then over time, galaxies started to form, stars, planets formed around these stars. They orbited, billions of years go by, and then you get the planet Earth. And you get a nice hospitable spot, and there's liquid water, and then you get life, with the beginning of amino acids and just the right combination. This is one version of the story. There are others, of course. Single cell organisms, and then you've got small little bacteria, protocells, and then you've got little bits of life in the ocean, and then bigger life in the ocean, and then life leaves the ocean. You've got reptiles and dinosaurs, and then eventually mammals, apes, primates, and eventually human beings, and that leads to today. So it's just one single train track, and there really aren't any alternatives that are available because of the prior conditions and the laws. There's this French thinker, Simon Laplace, who once wrote that if there's an omniscient being, an all-knowing being, that knew the state of the world at any point and knew all the laws, that it could perfectly could predict the future. So sometimes this threat to morality is explained in terms of God's perfect foreknowledge. If God is omniscient about the future, then the future is in a sense unavoidable. In a sense, we're forced into a single future course of actions, and that makes them unavoidable, and it's hard to reconcile the existence of human free will with that foreknowledge. So you can describe this threat of determinism without appealing to God or God's foreknowledge or an omniscient being. You can just talk about laws in the past, or if you want to incorporate God into the story, you can do that too. But either way, there seems to be a threat to our freedom, and if there's a threat to our freedom, then there's a threat to morality. And all of our theories about morality are incorrect. There's no right and wrong. It's just one big illusion. Let's do one more example of this threat to free will, one that's just very plain and straightforward. Take a simple decision, a simple act that many would consider to be free, like a decision or a choice about what to have for lunch. So if there's going to be freedom, there's got to be at least two available options to me. Usually we like to think that there are many options, sometimes hundreds or thousands of options. Just walk into a grocery store, all the different options for what you're going to purchase. But let's just keep it simple and say there's at least one alternative option. And in this case, you're deciding between a salad for lunch, maybe go a little bit healthier, or a grilled cheese sandwich. So before we make the decision, the belief is that both of these options are available. But if determinism is right, only one of them is available. So let's say that we end up going with the grilled cheese. I make the grilled cheese, I start to eat the grilled cheese, and maybe I reflect and I think, if I did it all over again, I could have had the salad. But if determinism is right, that belief is mistaken. If I go back in my time machine to this decision point, we could put that in quotation marks, this decision point, I would end up going with the grilled cheese over and over and over again, and the salad really wasn't on the table. So that's the view of determinism. The view that the conjunction of the past, or in other words, the state of the world at any point in the past, in conjunction with the laws of nature, like the laws of physics, the laws of chemistry, laws of biology, maybe even psychology, together they entail the future, the state of the world at any point in the future. And we could even include in that the state of the world at the present. And if this view is right, then for any decision point like this one, there's really only one course of action ahead of us, and any alternative is not available, even if it seems that way. It's that belief in the alternative is an illusion. So one of the readings for our course is from Harry G. Frankfurt, and this is a little bit cut off. But in the reading, he writes about the principle of alternate possibilities. So there's just traditional requirement for free will, or for moral responsibility, for that matter. person P performs action A freely only if P does A but could have done otherwise, so the could got cut off. But that's exactly the ability that we don't have. I want to say that I chose the grilled cheese, but I could have had the salad. I had grilled cheese, but I could have had the salad. And that's what makes me free. But if determinism is true, then I could not have done otherwise. If we went back in time and repeated it over and over again, I would go with the grilled cheese every time. So Frankfurt, we'll talk about this later, but Harry G. Frankfurt, he's an American philosopher, teaches at Princeton, still alive today, and he's been on The Daily Show with Jon Stewart in the past. Frankfurt believes that the path, the principle of alternate possibilities, is false, actually. And he comes up with a counterexample, a thought experiment, to show why he believes this. So we'll get to that in a little bit. But before that, let's talk about indeterminism. So in the last 100 years or so, scientists and philosophers have studied the world more and studied determinism more. And many of them have concluded that we don't have to worry about determinism. Determinism is not the case. The world is not determined. So what do they mean? Well, it turns out that at a subatomic world, determinism doesn't seem to be the case. So while the behavior of the pool table or of dominoes, the world of tables and rocks and chairs, while that may be determined, that when objects are really small at the micro level, the subatomic level, at the what so-called quantum level, the behavior of electrons and protons is not a deterministic world. It's indeterministic. So quantum events, like the behavior of electrons, is not determined. So philosophers for a moment thought, oh, well, this is great news. Because if determinism threatens our free will, and it turns out that determinism is false because the world's indeterminate, then our problem has just melted away. This is great. Well, the story doesn't end there. While it seems correct to say that the behavior of electrons is not determined, for larger objects in the macroscopic world, or at the macro level, so the size of a human body, or the size even of brain cells, and certainly the size of billiard balls and planets, that Newtonian physics, which is the deterministic physics, those predictions are going to still hold. So even if at a really, really small level there's this element of indeterminism, there's this element of randomness, this gets a little technical here, but it kind of ends up being negligible when the size factors in, when you get to objects that are very, very large, with in comparison to like a little electron. And even if human actions were indeterministic, so look at this fourth bullet point here, even if human actions were indeterministic, even if our behavior was like electrons, it's not quite clear that that would represent freedom, because the behavior of electron not determined, but that doesn't mean that it's free. It's more random. So, or it's either random or it's still within a framework of statistical probability. And so that's not going to give us free will either. Either our actions are just outputs of statistical probabilities, or they're just random. And either way, that doesn't seem to be like freedom either. random actions don't seem to be free. I mean, imagine someone that has Tourette's syndrome. They might have a facial tic, or they might blurt out words in a kind of involuntary way, in a random way. But are they freely saying those words, or is their face freely making those expressions or having those tics? Most of us would say no. So you can see the back and forth here. The belief is we have free will, but then science tells us about determinism, which seems to mean that we don't have free will and that there's no moral responsibility. But wait a second, then science, 100 years or 200 years after Newton, says, oh, determinism isn't quite right. Electron behavior of subatomic particles is not determined. So this threat to free will now goes away. But then the volley back is, well, these deterministic laws more or less apply to objects that are, greater than the size of, small molecules. And even if this indeterminism held for human actions, that still wouldn't automatically mean we're free. We might end up with just our actions are statistically predictable or they are random. And that's not going to do either. There was some hope that the neuron and in human the brain science behind human decision making, which is going to involve brain cells, these neurons and these neural pathways and this electricity in the brain, these neurons firing, that it might be that the indeterminism of the quantum world would somehow affect or spill over into brain activity. And the reason that some scientists and philosophers thought this is because there was a theory that the brain is a chaotic system. And a chaotic system is one where a small change very quickly can lead to a massive big change. So sometimes this is described as the butterfly effect, chaos theory, where a butterfly flaps its wings. That's a very small change in the environment. And then before you know it, there's, like a giant typhoon or hurricane that's going to hit some island on the other side of the world. So maybe some neural activity in the brain, some very small change, can lead to a very big change. Like instead of me making a grilled cheese, I make a salad for lunch. So maybe chaos theory will mean that our actions, even on this macro level, are more like the indeterminism inside the atom. Well, it turns out this is probably not the case because of something called quantum decoherence. That this that the behavior in the brain is going to be much closer to the behavior of classic physics of Newton, like that of a pool table, than it is going to be inside of the atom, because that quantum or subatomic indeterminism over time becomes negligible and it decoheres. That's why it's called quantum decoherence. So here's a statement about how determinism in the most universal strict sense is false, because inside the atom it's not true. So on the standard interpretation of quantum mechanics, that's physics about in the subatomic world, the physical world is not in fact deterministic, right? So it's indeterministic. But that indeterminism doesn't really play out once you get to the macro level, the world of planets and brain cells and billiard balls. And like I was alluding to, the parts of the human brain that relate to cognitive processes should be thought of as a classical or a deterministic system rather than an indeterministic system. Okay, I'm gonna hold. So that stuff gets pretty technical. It's almost like you're like, wow, I feel like I'm taking a neurobiology course in conjunction with a high-level graduate physics course. So I'm gonna hold you less responsible for the nitty-gritty and details of the science there. But what I will hold you responsible for is this position held by Frankfurt, is his thought experiment, his counterexample to the principle of alternate possibilities, the PAPS. This is in the reading. So for Frankfurt, he comes up with this really interesting case, and I'm going to embellish it and give the Ryan version of it. But he's going to try to come up with a case where the person in question does not have the ability to do otherwise. They could not have done otherwise. They were, in a sense, forced into an action. And yet, the intuition is that the action is free. Remember, the principle of alternate possibilities states roughly that if an action is going to be free, or if we're going to be morally responsible for it, that the person could have done otherwise. So they perform some action, but they could have done otherwise. So if I freely have grilled cheese, then I make the grilled cheese, but it needs to be such that I could have done otherwise. I could have made a salad. Frankfurt's can say, no, here's at least one case in this thought experiment that I'm about to present to you where the person could not have done otherwise, and yet the intuition is that there's free will. So the case goes like this. Imagine that you are brought into a room to participate in a psychology experiment. And you're brought into this waiting room, and you're told, here, sit in this chair, and we will come get you when the experiment is ready. And so the experimenter says, there's the chair, and then they leave the room. And then you're sitting there, and 5 minutes go by, and 10, and eventually you're starting to get bored. And you look around the room, and you notice it has two doors. We'll call them door A and door B. You came in through door A. And you notice there's another door. We'll call it door B. And there's a mirror behind you on the wall. And it turns out that this is one of those two-way mirrors. And there are experimenters on the other side of the mirror. They're watching you, and the experiment has already begun. Now, the experimenters, for whatever reason, they want you to walk through door B. Doesn't matter why. Maybe they'll get paid lots of money if you walk through door B. And they have rigged it so that if need be, they can push a button which will force you to get up and walk out of door B. Maybe the night before this experiment, they broke into your home, and while you were sleeping, performed some kind of neurosurgery and opened up your skull in the middle of the night, and they anesthetized you so that you were unaware of this. And they connected some electrodes in your brain, and now they can kind of control you like a puppet through Wi-Fi. And they sew you back up, and this is futuristic surgery, and there's no scar, no remnants. You don't have a headache. You don't remember any of this. You have no idea that they can control you if they want. So they got this big red button, and they're watching you through this two-way mirror, and they're monitoring your brain. And the second that you think about doing anything other than walking through door B, they're going to push this big red button, and it's going to force you to get up out of the chair like a puppet and walk through door B. But then here's the twist on this thought experiment. The experimenters, they're watching the monitors, they're watching your brain, they're monitoring, they got their hand hovering over the big red button. The second you think about doing anything other than walking through door B, they're going to push this button and force you to walk through it like a puppet. But after 15 minutes, you get bored, and then on your own, without them intervening, without them pushing the button, You get up and you decide to go investigate. You decide to go walk through door B, figure out what's going on. And they never push the button. So they don't force you to do it. You do it on your own. So now Frankfurt asks the reader or the audience, that's you, did the person in the chair freely walk through door B? And when you poll philosophers or you poll any sort of audience like you guys, most people believe that the person did walk through the door freely. And if that belief is right, then Frankfurt has succeeded. He has provided a counterexample to the pap. Why? Well, because he's presented a case where somebody freely performs an action, in this case, walking through a door, door B, right? It seemed like it was free. When you voted, most of you voted that it was a free action. And yet, think about it. Could that person have done otherwise? Could they have avoided walking through door B? The answer is no, because the second they even thought about walking, or thought about doing anything else, like walking through door A, or even just staying in the chair, what are the researchers going to do? They're going to push the big red button and force you to walk through door B. So no matter what, you're walking through door B. Just like in the grilled cheese scenario, no matter what, you're making the grilled cheese. Even though when you're sitting in the chair, it seems like you don't know about the surgery, you're not aware. It seems like you could go back through door A. It seems like you could sit in the chair for as long as you want. It seems like you could stand up and walk around, or maybe find a window and try to break it and jump out. It seems like all these things are possible, but those are just illusions. You aren't able to do any of those things. Because the second you even think about performing any of those actions, the big red button's going to be pushed and you're going to walk like a puppet through door B. Just like in the case of the grilled cheese, we make the grilled cheese, but we couldn't have done anything else. At the moment when we're making the quote-unquote decision, it seems like we could make the salad, but that's not possible. Because, the laws in conjunction with the state affairs, in a sense, is like they'll push that button if we think about doing anything else. So again, what is the PAP? It's the principle of alternate possibilities. And what does it state? It's the principle that freedom or morality requires that one could have done otherwise. And Frankfurt says, no, here's at least one case where there is freedom. The person, we say they freely walked through door B, but they could not have done otherwise. So freedom can't require that we do otherwise. And why does this matter? Why does it matter that Frankfurt has potentially defeated the PAP? Well, if we can show that the PAP is false, then maybe we can subscribe to a philosophical view called compatibilism. The view that our actions can be determined, and yet we can have free will at the same time, that free will and determinism are compatible. There are philosophers who argue that the world is determined and we don't have free will because of it, and those are called hard determinists. They accept determinism and they think that we don't have free will, and maybe even further, that we don't have moral responsibility. But then there are some philosophers like Frankfurt who accept the thesis of determinism, and yet they think that free will is possible. So they're compatibilists. They're compatibilists. And this might be a way out for people who are scientifically minded, who see that the world does seem to be governed by these physical laws, and in conjunction with the past has this, push, this effect on what we do in the future. But maybe that's okay. We can still be, in a sense, forced, by the past and the laws to perform all these actions, but freedom is still possible, just like in the case of the neuroscientists behind the mirror. All right, thanks for listening. That concludes our lecture on the relationship of ethics or moral responsibility and determinism.